Hello guys and welcome back to the GCE Math Panel online with Math 24 Super Channel. In this particular preparations, we are looking at simultaneous equations. Our focus will be on the elimination method, the substitution method, the matrix method, the graphical method, remarks on simultaneous equations, and problems leading to simultaneous equations in daily life. I urge you to watch this video to the end and to equally click on the subscription button and the notifications bell so that you get an update immediately a video is uploaded. I implore you to watch this to the end and don't forget to share this content. Let us begin.
Two equations, equation 1 and equation 2. This pair of equations is what constitutes a simultaneous equation, two equations with two unknowns. Elimination means to make one variable disappear, and this is by adding or subtracting both equations.
Good, so you got that clear introduction. So let us start with this example. So we have two equations, x plus 2y is equals 4 and x plus y equals 3. We call them equations 1 and equation 2. This is a pair of equations and it is known as a simultaneous equation. A simultaneous equation is a pair of equations with two unknowns. Let us see how we can solve this example using the first method. So elimination means to make one variable to disappear, which means that we are either going to be adding, subtracting, multiplying, doing whatever, but the end result is that one of the variables should disappear or eliminated. So this is done by addition, subtraction, or both. So let's add and see if any of the variables is eliminated. Let us add and see. So if we add equation 1 to equation 2, we are going to have x plus x plus x. What does that give us? 2x. Now we have 2y's plus y. That gives us 3y's. 4 plus 3 equals 7. Now the big question is, has any variable disappeared? No, I still have x and y after adding. This therefore means that addition has failed and I will need to actually use a different method. So addition has failed, neither x nor y has disappeared. So what do we do now? Let's try subtraction. So we try subtraction. We are now going to have x minus x, that gives us 0. X has disappeared. So subtraction has worked. And 2y's minus y gives us 1y or just y. 4 minus 3 gives us 1. So we have the result, which therefore means that subtraction worked. So with the elimination method, you either eliminate x. If you try addition, it does not go. You try subtraction, if it does not go, there's what you call balancing or multiplication, which you can now use. If all of these fail, then that simultaneous equation has no solution. All right, so yeah, x has been eliminated, so subtraction worked. Y is already the first part of the solution. Whenever you solve a pair of simultaneous equations, you are supposed to have two answers. The values may be the same, they may be different, but you have two different answers or more, or three answers, for example, for advanced level where you have a pair of equations or three equations with three unknowns. So using the value of y, we now substitute in one of the equations. We substitute any of the equations to find the value of x because we have y, but we don't yet have the value of x. So using equation 2, we are going to have x plus a certain number to be equal to 3, but from equation 2, we have x plus y. However, our y is equal to 1. So x plus 1 is equal to 3, and therefore x should be equal to 3 minus 1, which is 2. Thus, x is 2 and y is 3, as easy as it is. The good thing is that as you are watching, it's good that you solve many more examples because this is not a movie, a Nigerian movie, a Cameroonian movie that you just watch. You have to have the skills by drill and practice continuously. Okay, let's take another example. So in this other example, we have the pair of equations 3x plus 2y equals 11 and 2x minus 2y equals 14. So we observe that y can be directly eliminated. Can you see that? Y can be directly eliminated. If you add these two equations, y will disappear because we have plus 2y's plus minus 2y's. That is going to make us to have y being eliminated. So addition worked. So you must always check and see if you add or subtract to eliminate one of the variables, or you have to do some sort of balancing somewhere. So here, if we add the two equations, we see that something eliminated. If we subtract, neither x nor y disappears. So we are going to do addition. So 3x plus 2x is going to give us 5x, and plus 2y plus minus 2y is going to give us 0. So y has disappeared. There's no need to even put this 0 here. I'm just putting it for formality. Now we have 11 on the right-hand side plus 14, giving us 25. So from here, we have 5x is equal to 25. And dividing all through or both sides by 5, we are left with x to be equal to 5. So x is equal to 5. Now that we have x to be equal to 5, we need to look for the value of y. And we can do that by substituting x in any of the equations above. And we are going to have the value of y. So let's use equation 1 and see what we obtain. So using equation 1, we are going to have 3 into a certain number plus 2y equals 11. Because we already have the value of x to be 5, we are going to say 3 plus x, which is now 5, plus 2y to be equal to 11. That gives us 15 plus 2y equals 11. And 2y, that if we subtract 15 from both sides, we'll have 2y is equal to 11 minus 15, or as you usually say, carry 15 to the right-hand side, and the sign changes. So we have 2y to be equal to minus 4, and y will be equal to minus 2. So our solution set is x equals 5 and y equals minus 2, which you can write as an ordered pair. Please don't forget to watch the next tutorial, which is on quadratics, and the previous one, which is on indices, logarithms, and surds. Now let's take this other example. In this case, direct addition might not work, direct subtraction might not work. We need to do some sort of balancing, or you call it multiplication or whatever, but some sort of balancing, okay, so that something can be eliminated. So here, what if the addition and the subtraction both fail? So let us consider this equation. If we do addition, addition has failed because nothing has been eliminated. Subtraction also fails because nothing is eliminated. So what next? Next thing to do is to do some balancing. So we balance coefficients by, follow this one very well, we balance the coefficients by multiplying, that is swap or exchange coefficients. Swapping or exchanging coefficients. Let's see what I mean by swapping or exchanging coefficients. So step 1, we swap multiply. Look at how we are going to do it. I want to use these first ones here. So we have, I'm swapping the coefficients. Let's say we have chosen to eliminate x. I want to work with the x. We have chosen to eliminate x. I want to work with the x. So we multiply equation 1 by 2. Look at it. We multiply equation 1 by 2. We multiply all of equation 1 by 2, by 3, I'm sorry. And we multiply all of equation 2 by 3. So this 3 moves up, 3 upwards. Multiply all of equation 1 by 3, that is the swap multiply. And we are going to multiply all of equation 2 by which number? Good. We are going to multiply equation 2 now by the coefficient of x in equation 1. Look at it now. So you can now see that we are going to multiply by 2, all of equation 2 by 2. I hope this is clear. All right, let me take it again. So we are going to do what we call swap multiply, because addition has failed and subtraction has failed. So this is what we are going to do. Let's say we have chosen to eliminate x. So I'm working with this 2x. So in this case, I'll multiply equation 1 by the coefficient of x in equation 2. So I'll multiply equation 1 by what? By 3. I'll multiply equation 1 by 3. And equation 2 by what? Equation 2 by 2. That's coefficient of x in equation 1. Can you see we have just swapped So you just solve the position of these coefficients and multiply. If you decide to use y, then you're going to use these coefficients 1 and -2. So at this -2 multiply equation 1, and then +1 multiply equation 2. Take note. So this gives us the following. So when we multiply, we're going to have 3 times 2x, 6x, plus 3 times y plus 3y equals 3 times 3, 9. Now equation 2, 2 times 3x is 6x. 2 times minus 2y is minus 4y, and 2 times 1 is 2. So now we can see that the coefficients of x are the same, right? This is where we wanted to arrive, and that is where we are. Now that the coefficients are the same, we can now do a subtraction, and we call these new equations equation 3 and 4. We can now do a subtraction, and we will eliminate x. So we have 6x minus 6x, that will give us 0. Then 3y minus 4y should give us +7. See, the minus signs are not separated by anything. So you have 3y minus 4y. These two minus not separated by any number becomes a plus, because this one means minus times minus is plus. That gives us 7y to be equal to 9 minus 2, which is 7. We now divide both sides by 7, and y will be equal to 1. So we can now substitute that y equals 1 in any of the equations above to find the value of x. Let's use equation 1. So I'll have 2x plus, instead of writing y, I'll have 2x plus 1 is equal to 3. 2x equals 2 and x equals 1. So x is 1 and y is 1. You can even test the answers in these equations. Solve more. That is the secret. If you need the notes of this lesson, you can get this note of this lesson at Math 24 Super Channel or GCE Math Panel or gcepreps.blogspot.com. www.gcepreps.blogspot.com. You can equally register there for private lessons and all sorts of lessons from any country, because you can pay in any currency, and we will help you or facilitate you. Okay, let's look at some worded problems. These simultaneous equations do not come from space. So at times, the equation is in worded form. So let's take this example and form equations. So I'm taking this example of one of these, my very good friends. The sum of two numbers is 5, and their difference is 1. Find the two numbers. This is a simultaneous equation. So the sum is addition, right? Don't forget. Sum of these two numbers, so the sum. So we'll start by saying that the two numbers should be x and y, or a and b, or whatever. So we define the two numbers. So let the first number be x and the second number be y. Using the first part of the equation, we obtain the sum of the two numbers is 5. So that will give us x plus y to be equal to 5. That is the sum. So the first number is x and the second number is y. So x plus y equals 5. We now use the second part of the equation after we obtain our equation 1. The second one is saying that their difference means subtraction, their difference. The first number I called was x, so I'm going to say x minus y. So the difference is 1. So x minus 1 minus y rather is equal to 1, and this gives us equation 2. So these are the two equations, and from here you can now solve to find these two numbers using elimination. Okay, so normally when you solve, what are you going to have? Yes. So by direct elimination, equation 1 minus equation 2 will give us x minus x is 0, y minus minus y is 2y to be equal to 4, and y will be equal to 2. And if y is equal to 2, then x will be which other number? Well, x must be equal to 3, because you have a 3 plus 2, which is 5, and 3 minus 2, which is 1. So that's the solutions. Another example, Cynthia and Mike go to the mall. And at the mall, Cynthia buys 2 books and a pen for $7, while Mike buys a book and a pen for $4. Find the cost of the pen and that of a book. English language is very, very important in this question. The two of them go to the mall, so we assume that it's the same time. So inflation, economics, and other aspects do not have any impact on this because the shops are not different. So we assume that they're selling at the same prices. They buy the same items, but they buy in different quantities. So let's see, we have let a book be X because they buy a book, let a book be X, and they equally buy a pen, let the pen be Y. You can use A and B, you must not use X and Y. You can use A and B, C and D, whatever thing that will make you happy. So the first part of the equation gives us, Cindy buys 2 books. So we have 2X and a pen. A pen is 1 pen. So 2X plus 1Y, or just 2X plus Y. So 2 books plus 1 pen for $7. Write it now in mathematics language. 2X plus Y equals 7. Secondly, for Mike, he buys a book and a pen. So 1X and 1Y, right? 1 book and 1 pen equals $4. So 1X plus 1Y equals 4. Just X plus Y equals 4. So from here, we can proceed to elimination. Subtraction will work directly. Equation 1 minus equation 2 will give us $3 for X. Okay, so a book is $3, and obviously a pen should normally be $1. So you can work out this in FCFA, in Naira, in Euro, whatever it wants to do. Okay, so if the coefficients are same, so these are some remarks that you have to take the decision on elimination. Which equation should I choose, or what should I do? Should I do addition, or should I do subtraction, or should I multiply? So this is the rule. If the coefficients are same but have opposite signs, let me say you are considering Y. I'm considering Y in this case. Look at it. In equation 1 and equation 2, the coefficients of X and Y are the same. Can you see? But their signs are opposite. They are 2 and 2. So whenever the coefficients are the same and the signs are opposite, do what? Do addition. Do addition. If you go and do subtraction, it will not work. You will fail and you'll be wasting time. After you do the subtraction, you start it fails and you come back to do addition. Now, another thing, because in this case now, if you decide to eliminate the X, then you must do balancing here, okay? Or swapping coefficients and multiply. Now, the second thing, look at this other equation. Now, look, the signs, the coefficients of X of Y are the same. They are the same, and their signs are also the same. So whenever the coefficients and signs are the same, what you do should be subtraction. Because when you subtract 2Y's from 2Y's, it's 0. So elimination will work. However, if none of the coefficients are the same, the signs are not also the same, what you have to do is you have to do balancing or multiplication. That brings us to the end of solving equations, simultaneous equations using the elimination method. Let's look at the next method, which is simple. But don't forget to subscribe and to click on the notifications bell so that you get all the updates as soon as the next video is uploaded, okay? Now, let's look at the substitution method. We take just 3 examples and we go to the graphical method, which is what you are actually waiting for so much, I'm sure. So we have already done part of this method in the first, which is part of substitution. So the substitution method is all about making one equation the subject of the formula and substituting the other. Please, you can watch a short video on transposition of formulae and simultaneous equations, or just transposition of formulae or making the subject of the formula. But from solving simple linear equations, you have an idea. It's just like to solve X, okay? So we make one the subject of the formula and then we substitute in the other. So I want to make X the coefficient, the subject of the formula. So from these 2 equations, it will be good. Always take the one that is just 1, like 1x. Look at this one, 1x. It's good to make this one the subject of the formula, or this plus 1y x in equation 2. It's good to make this one the subject of the formula. If you have to take 2y's and make the subject of the formula in equation 1, you will have to do more steps and you may easily make mistakes. So with this type of equation, if you choose equation 1, it is good to make x the subject of the formula. If you choose equation 2, it's good to make x the subject of the formula so you avoid some errors. In equation 2, you can equally choose y, which will still be good. But in my own case, I prefer to take the y to the right-hand side and bring x to the left-hand side, as we say it in class now. That is, yeah, as I'm saying using our language, okay? So if I'm using equation 2 to make x the subject of the formula, if you now carry this, I'm using the class language, if you now carry this minus y to the right-hand side, this is actually adding y on both sides. That is adding 1y on both sides. Carry this minus y to the right-hand side becomes plus y. So we now have x is equal to 1 plus y. It was minus y. When you cross the negative sign, becomes plus y, okay? So now I have made x the subject of the formula. Oh, I have transposed x. I've done transposition of formulae. I will now, since I use equation 2 to do this, listen attentively. Since you use equation 2 to do this answer that you have that you call equation 3, you have to substitute now but in equation 1. So since you use equation 2 to obtain this, you substitute in the other equation. If you use the equation 1, you substitute in equation 2. If you use equation 2, you substitute in equation 1. So I have to substitute this value in equation 1. So in equation 1 now, I'm going to replace x by what I have solved for here. So this x, so a certain number, this x plus 2y equals 4. So what am I going to put here? I already have my x to be 1 plus y, right? So that is it. So my x, I'll replace this. I've replaced x by 1 plus y plus 2y equals 4. We now simplify. Y plus y is plus 2y is 3y. That's equal to 4. And we carry 1 to the right hand side, becomes minus 1. So 4 minus 1 is 3. Okay. And 3y being equal to 3, divide both sides by 3y will be equal to 1. We now substitute this y equals 1 to look for x. It's good to always use the equation. You can use any of the equations. Listen, you can use any of the equations, but most people always use this one that they used here, okay, because it's going to be faster. So we now substitute this y value in equation 3 or any other equation to find the value of x. So this gives us x plus y. X is equal to 1 plus, what's the value of y now? Y is 1. So x is equal to 1 plus 1, and that gives us x is equal to 2, like ABC. This is not a Ghanaian movie or a Nigerian movie or an Indian movie or a Nollywood movie. You have to solve daily to have the skills. Somebody who keeps on solving has more skills than somebody who keeps on watching the video. So even if you watch, you have to solve. You can watch and solve and watch again. Right, so same like previously with this other example, we make one equation the subject of the formula and substitute in the other. So which one should I choose to make the subject of the formula? It is best for me to choose this y in equation 1 because it's standing alone with just one y. It makes the work easier, faster, and reduces errors. Okay, so from equation 1, we have, I'm using equation 1, sorry. Equation 1, we have y, this y here, will be equal to 3 minus 2x. Okay, so y is equal to 3 minus 2x. Let me call it equation 3. Since I use equation 1 to make this equation or to come out with this equation, I'm going to substitute in which of the equations now? Good, in equation 2, because I use equation 1 to come out with this equation 3. So since you use equation 1 to obtain this, you substitute in the other equation, that is 2. And what will this give us? In equation 2 now, I have 3x minus 2y to be equal to, so we have 3x minus 2y, but my y is equal to 3 minus 2x, right? Remember, this is substitution. So I'm going to substitute it here. Good. Then my y now becomes 3 minus 2x equals 1. We expand. So we have 3x minus 2 times 3, so minus 6. Minus 2 times minus 2x is plus 4x. That should be equal to 1. Bringing like terms together, we have 3x plus 4x, 7x. We carry this minus 6 to the right-hand side. They become plus 6 plus 1 gives us 7. So we have 7x equals 7, and x is automatically equal to 1. We now substitute this value of x equals 1 in this equation 3 to find the value of y, okay? Or in any other equation. So this gives us y to be equal to 3 minus 2x, but my x is 1. So since x is equal to 1, we write 1 here. 3 minus 2 gives us 1. So y is equal to 1, and our x is equal to 1. Simple also as x, y, z. Don't forget to subscribe and to leave your notifications. Please share our videos on Facebook, WhatsApp, Snapchat, so that others may come to benefit from this knowledge. Thank you so much. And please, that's the only thing you can really do to patronize us. If you're interested in online classes, please, you can get to our blog, gcepreps.blogspot.com, www.gcepreps.blogspot.com for special classes in other subjects, not just mathematics. Or you can contact us from gcemathpanel.blogspot.com. Okay, now let's look at solving these equations now by the graphical method. The graphical method. After the graphical method, we'll look at the matrix method, and that will be the end of this particular episode. So by the graphical method, let's take an example. We have equation 1, x plus y equals 3, and x minus y equals 1. So what we are going to be doing here basically is the first step is to make a table of values for each equation. This table of values, you can take just 3 values of x, 2 or 3. 2 are okay, but to avoid errors, it's always go to 3. That is what I always advise my students to do. So we make a table of value. Let's start with the first equation, x plus y equals 3. If I'm speaking very fast in this video, you can go to your YouTube and the video in YouTube and reduce the speed a bit, okay? And I'll speak according to your pace. All right, so now I'm going to make a table of values for x and y. I'm going to start if x is equal to this, y will be equal to that, and so on. I'll take values which are very close to 0. That's one of the key things. So I have my x and I have y. So let me start with the values of x. Let me take, for example, 0. So in this equation here, if x is equal to 0, if x is equal to 0, put 0 inside, substitute x equal to 0 here. You have 0 plus y equals 3. 0 plus y is y. So y will be equal to 3, right? So we solve this. We are going to have 3. Now, if y is equal to 0 instead, x was 0, now is y. If y is equal to 0, I'm going to have x plus 0 equals 3. So x will be equal to which number? X will be equal to 3. Now take any other value for x. You can stop here, but it's always advisable to take another value, because if the 2 points you make have an error, you will not know. But if there are 3 points and one of the points does not fall on the same line that you're going to put your ruler to rule it, it means that there is a problem and you can check. That is one of the small tricks, okay? So I advise that you always use 3 points. So let's take another point apart from 0. Let's take, for example, x is 1 or y is 1 or something like that, okay? So let's take if x is equal to 1, you put here, you fit. You have 1 plus y equals 3. 1 plus y equals 3. So if 1 plus which number will give us 3? So y must be equal to 2. Okay. Now with these 3 points, you are safe. Yeah, you are safe. So we do the same thing with the second equation, x minus y equals 1. We make a table of values for it also. So we have x, we have y, and we start if x is equal to 0. We always take values very close to 0, okay? Because if you take very big values, you may make a lot of errors. So if x is equal to 0, you substitute this equation, you have 0 minus y is minus y. So minus y will be equal to 1, and y will be equal to what? Minus 1. Now, what if it is y that is equal to 0? If y is equal to 0, you have x minus 0, which is x. So x will be equal to 1. And take another number again, very close to 0. Any number that you are running away. I am running away from having a fraction, so I'm taking x equals 3. X equals 3. I have 3 minus which number will give me 1? 3 minus 2, right? All right, so 3 and 2. So if x is equal to 3, then y should be equal to 2, because 3 minus 2 is equal to 1. So step 1 is complete. I have made these tables. The next step is to plot these points. So I'm going to plot these points or sketch this on the line above. I already have my Cartesian plane here, or XY plane, and you can see how it is well drawn out. So I'll start with this first point, with this first equation. So when x is equal to 0 and y equals 3, that's the first point. So we have the point 0, 3. When x is 0, y is 3. So this is the point. Can you see? Note that the y-axis is the line x equals 0. Along this line, x is always equal to 0. So x is 0, y is 3. This is the point. The next point is when x is 3, y is 0. This is it. When x is 3, y is 0. The next point, when x is 1, y is 2. When x is 1, y is 2. I now use a ruler to link these points. Can you see that all these points fall on the same line? If there is a mistake, one of these points will not fall on this line. And you can easily go back to check your work. So that's why taking these 3 points is very, very important, as I have explained before. Because if there's an error, you can always go back and check. Now we do the same thing for the second equation. We have the first point there, which is 0 minus 1. So this is the line x plus y equals 3. So we have when x is 0, y is minus 1. So x is 0, y is minus, now when x is equal to 1, y is 0, this is the point. And the last point is the point 3, 2. When x is 3, y is equal to 2. You link these 2 points again. So you can now start all the points against it fall on the line, which is a very, very good thing. Now the points where these 2 lines meet gives us the coordinates of the solution, okay? The x and y values which we are looking for. So this second line is the line x minus y equals 1. So this is the point of intersection when x is equal to 2 and y is equal to which number? 1. So the solution of this is x equals 2, y equals 1. You can see that is very interesting, it's very easy. We take another example, yet another beautiful example. Yes, the cartoon is coming to greet us. Yeah. That's math just a bit crazy, you know. Yeah. So the second equation, so you just need to fill in the values of x plus 2y equals 1 and x plus y equals 0. So we make a table of values to the first equation, that's step 1. So if x is equal to 0, you can start with y equals 0. In this case, I'm running away from fractions. So if y is equal to 0, you have x to be equal to 1. I want to run away from fractions. Now let's take another number. Now, if y is equal to 1, you can take another number. Any numbers that you take that satisfies this line, you will have the same line. You must not have the same values with their friend because it's a line. A line is an infinite set of points. It means that if you're working with x equals 10 and y equals this, or x equals 100 and y equals this, you will have the same solution at the end. But because you have to sketch, it's good that you take values which are very close to 0. So yeah, if y is equal to 1, you have x plus 2 times 1, that's x plus 2 is equal to 1. So x must be equal to -1. And you can take 3, if x is equal to 3. So 3 plus 2 times which number will give us 1? So y should be equal to -1, so that times 2 gives us -2. And we are going to have y to be equal to -1. We do the same thing now with the second, okay? So as I've said, note if x is equal to 0, y will be equal to 0.5, but it is good avoiding fractions. Normally, I can use fraction on this my own of 0.5, which is good because it is going to fall on the line. Any point which does not fall on the intersection of two lines is a bad point. Are you getting what I'm saying? Any point that does not fall on the intersection of 2 points means where 2 lines cross, like this point, this is the point. So any point that does not fall on top of any of this is a bad point. That's what you should know in curve sketching. So this x plus y equals 0 now. You have x and y values. X is equal to 0, y is 0. If x is equal to 1, y should be -1. X is equal to 2, y should be -2, right? The second one, you now sketch these points. So we have the first point here is 1, 0. This is it we have sketched. X is 1, y is 0. The next point is -1, 1. X is equal to -1, y is equal to 1. Then we have 3, 1. X is 3, y is -1. 3 minus 1 rather. We roll a line. So this is the line x plus 2y is equals 1. Now for the second, we have the point 0, 0, which is at the center. Then we have the points 1 minus 1. This is it. And the last point is 2 minus 2. We roll a line for this x plus y equals 0. Note that the line x plus y equals 0 is the line that passes through the center of the Cartesian plane and has a gradient or slopes from right to left downwards. So the point of intersection is this point where x is -1 and y is 1. As you can see, x is -1 and y is 1. So that's the solution for this equation. And with this last one, this is the last example on this. So the first line, we take, for example, if x equals 0, y will be 3. If x equals 1, 2 times 1 is 2. So 2 plus which number will give us 3? Y should be 1. And if we have x equal to 2, 2 times 2 is 4. 4 plus which number will give us 3? 4 plus -1. We do the same thing for the second line. Okay, so we avoid fractions because we want to have bad points. Points that do not fall on the intersection of two lines are bad points. So here we have x and y with the second equation. If y is equal to 0, look at it, you choose your points wisely. If y is equal to 0, x will be equal to 5. Okay. Now, if x is equal to 2, 2 minus 3 times which number will give us 5. So if x is equal to 2, we have 2 minus 3y equals 5. So minus 3y will be equal to -3 and y will be equal to -1. Equally, if x now is equal to -1, you will have -1 to the right-hand side. What happens? It becomes now +1. -3y is equal to 6 and y will be equal to -2. So we now plot these are points. We have the point 0, 3, 1, 1, and 2 minus 1. We can have the points 5, 0. Okay. We have the points 5, 0 here, 5, 0. Then we have 2 minus 1. So we have the point 2 minus 1. It's 2 and -1. And the last point there is -1, x is -1 and y is -2. This is the point. So we link these 3 points. And you can see the point of intersection there, right? So when x is 2 and y is -1, that's the solution. So we round up by looking at the matrix method of solving these quadratic equations, and we're going to look at some important remarks about lines. So note, we are going to look at this again in coordinate geometry, because we can equally talk about this in quadratic coordinate geometry. So if the two equations, the first line and the second line, have the same gradient, then our simultaneous equations will not have any solution, because the two lines will not intersect. Okay, you can see there are parallel, there will be parallel lines. Then if one line lies on the other, then we'll have an infinite number of solutions, because one line is on the other one, because it means that one line will always be equal to the other. So we can say the two lines lie on each other. And then the third one, if the lines are at right angles, that's the perpendicular, they form an angle of 90 degrees, then there will be just one solution also. So the general form of the equation of a line is given by ax plus by equals c. This is the general form. Then from here, this type of line like this, it will slope upwards from left to right if a and b have opposite signs. So if the coefficient of x and the coefficient of y have opposite signs, then this thing will slope upwards like this. But if their signs are the same, then it will slope downwards like this. And these are examples of equations like that. So ax plus by equals c can also be written in the form y equals mx plus k. And this one is called the gradient intercept form, where m is the gradient and k is the intercept on the y-axis. So we round up now with the matrix method to solve simultaneous equations. And this method is very easy. We are going to look at matrices in the subsequent chapter. So to solve a system of equations by using this method, we need three things. The first thing is to form the matrices M, U, and C. So we form the matrices. Then secondly, we find the inverse of the matrix M, where M is the coefficient matrix. That's the coefficients of x and y in equation 1 and equation 2. M is the coefficient matrix. This matrix U is just the x, is just x and y. And this C are those values that you have on the right-hand side, okay? So that brings us to step 3, where we are solving for U. This U, like this, the matrix with coordinates, with entries, x and y. So the values of x and y will just be equal to the inverse matrix, inverse of the coefficient matrix times the constant matrix. So for example, let us solve this system of equation. We have x plus y equals 3 and x minus y equals 1. So in step 1, we form the matrices. The first thing is to form the matrix M. We get the coefficients. Coefficient of x in equation 1 is 1. Coefficient of y in equation 1 is 1. So we have 1, 1 in equation 2, 1 minus 1. The coefficients of x and y only in the first matrix. So we have 1 for this position, 1 for this position. Then we have 1 for the other position. And we have minus 1 for this position. Can you see? Just copy the coefficients and put. Now, what are we solving for? X and y. We write x here first, then followed by y. What are the constants on the right-hand side? 3, 1. Just copy them as they are. So this is our matrix M. This is our matrix U, and this is our matrix C, as you can clearly see now. M, U, C. Okay. We are solving for the matrix U, which has coordinates entries x and y. So to do this, we need to find the inverse of matrix M and pre-multiply it with matrix C. So matrix M, the determinant is given by the product of the leading diagonal. This is the line. This line like this is called the leading diagonal. Look at it, like coupe, and this other one is décalé. Okay, yeah, that's what my students usually say in class. So like this, you cut it the right hand. So you have the product. You have 1 times minus 1. Okay, can you see? 1 times minus 1. Now this other one is the off diagonal or the reverse diagonal. The other one now, 1 times 1. Okay. So what did this give us? You have minus 1 times minus 1 is minus 1 minus 1, which is minus 2. So that's the determinant of the matrix M. Now the adjoint of this matrix is given by, let's call it the adjugate of the matrix. So the adjugate, you just have to swap the leading diagonal entries and change the signs in front of the off diagonal entries. So this is a matrix M. I'll swap the positions of this leading diagonal of these coupe people. Look at it. I'm going to, this man will come to this other position, this other guy will move to the other position. So we swap their positions. Can you see how we have swapped their positions? And then for these other ones that we have not touched, any sign that they have, we change it. Well, their signs are the same. In fact, any sign that this position, this entry has, change it. So, and the other one also change it. Okay, so you can see that this one was positive, positive becomes negative, this one was positive becomes negative. If it was negative, it becomes positive. The two of them must not be the same. If one was positive and negative, the other one was negative, one will now become negative and the other one will also become positive. So our inverse matrix is given by 1 over the determinant, our determinant is -2, times the adjugate. Can you see? So 1 over this determinant that we have times the adjugate. That's our inverse matrix. We are now in step 2. Step 3 now, we just have to take this answer and multiply by C. Sometimes they may ask us to solve like this in the exam. So matrix U will be equal to, these are inverse matrix, this is it, times C. We will still touch this topic again when we are looking at matrices. So when you're watching at the part on matrices, you'll still see this topic. So we have a half, that's minus a half, I'm sorry, into -1, -1, 1, -1, 1, then times this constant matrix 3, 1. Okay, so this gives us minus a half into, now we have -1 times 3. Can you see? -1 times 3 plus -1 times 1. So it means that this first row times this column. First row of matrix 1 times column of matrix 2, okay? Now we are finished. Now this one, the second row now. So -1 times 3, this one and this one. -1 times 3 plus 1 times 1. So this gives us minus a half into -4 and -2. So multiply each of these entries by minus a half. That will give us 2 and 1. So the values of x and y are 2 and 1 respectively. We have solved this in the previous example, so you can equally see that the answer is the same. Okay. So if you not get this step, you can get the video again. If you need the notes on this lesson, you go to GCE Math Panel online, or you go to the GCE Prep platform where you have the notes better. But I think it's partly paid. So to have the notes there, it might be partly paid. So this second example, we still follow the same procedure. Now you have understood. If you don't understand, you take it again. You see it's going to be simple. So we start by looking at the coefficients of x and y. So we have 1, 1, 1, 2. Okay, 1, 1, 1, 2. We are solving for x and y, x and y. Coefficients on the right-hand side of the constants, 1 and 0. Now find the determinant of this matrix. 1 times 2 minus 1 times 1. So the determinant of matrix M is 1 times 2 minus 1 times 1. That gives us 1. The determinant is 1. Now we look for the adjugate of M. Change the position of leading diagonal entries, swap their positions. Instead of 1 and 2, I'll now have 2 and 1, and then change signs in front of the off diagonals, -1 and -1. Find the inverse, step 2. Inverse will just be 1 over determinant times adjugate, 1 over 1 times that, which is the same thing. And step 3, find the inverse. Inverse will be equal to, you now take this one you will start by using the inverse and then multiply with the constant matrix. So you have 2, you must not put this 1 over 1 here because 1 divided by 1 is 1 times the same, it does not change. So 2 minus 1 minus 1, 1 times 1, 0. We simplify. So this will give us 2 times 1 plus -1 times 0. Now -1 times 1 plus 1 times 0. So this gives us 1 into 2 and -1. The values of x and y are 2 and -1 respectively. 2 and -1 respectively. Don't forget to subscribe, and you subscribe, don't forget to click on the notifications bell so that you get all the notifications once you upload a video. Don't forget to share these videos on your WhatsApp groups, on your Facebook pages, and others so that they may have access to these videos, and it is going to motivate us to produce more. Leave your likes, leave your comments down so that we know on the next moves, and we know what equally we can add to make sure that we satisfy the public out there. So this is the last example, just crash 2. So we have 3 to 5 minus 4 You have xy we are solving for, and then 13, 7. We start by looking at the determinants. 3 times minus 4 into 2 times 5. So we have minus 12 minus 10, which is minus 22. We look for the adjugate of the coefficient matrix. We swap these positions first. So we have minus 4, 3. And then we change these signs to minus 2, minus 5. The inverse is 1 over these determinants, 1 over minus 22 times this adjugate. Okay, I can just leave it like that. Now move to the last step, m inverse times c. So we have 1 over minus 22 into minus 4 minus 2 minus 5, 3 times the constant matrix, which is 13, 7. You do a multiplication and you arrive at the point where x is equal to 3 and y is equal to 2. So this brings us actually to the end of part 6 of these preparations. And please watch the other preparations, or you can go to our page and see the outline of these preparations. You can get it at GCE Preps online. That's www.gcepreps.blogspot.com or gcemathspanel.blogspot.com. And thank you so much. We have these two past questions. These are multiple choice. We have 3x plus 2y equals 3 and mx minus 2y equals 4, such that the line L1 is parallel to L2. Then find the value of m. So two lines are parallel if their gradients are the same. So with this one, we write it in gradient intercept form. That is, we solve for y. This coefficient of x now becomes the gradient of the first line. We do the same thing with the second line. Now, since the question says that the two lines are parallel, look at these two lines. It means that what's in front of x in this line 2, should be the same as the number in front of x in line 1. That's the coefficient should be the same. So what does this mean? It means that minus 3 on 2 is equal to m on 2. From there, m is equal to minus 3. And that's the solution. Another one, you are given this matrix, this. Find the inverse of the matrix, hence solve the system of equations. This was 2018. Hence, you can see that I've used this method to solve, right? Many students may run away from this, and this is what they'll meet in the exam. So we start by, we just follow the procedure which I have just explained above. The determinant of m is this, that is product of leading diagonal, 2 times minus 1 minus 3 times 3. That's going to give us negative 11. Now the adjugate is to swap the positions of the leading diagonals. So we have minus 1 and 2 now, and change the signs in front of the off diagonals. So we now find the inverse. Our inverse is going to be equal to 1 over these determinants times this adjugate, okay? And then you simplify. I've left it like this, but it's good to simplify. So when you simplify, you're going to have 1 on 11, 3 on 11, 3 on 11, and 2 on 11. So B, hence solve the system of equations. To solve the equation, you start, this is the coefficient matrix 2, 3, 3 minus 1, right? So I'm just going to take this, my inverse, and multiply it with this constant matrix minus 11, 22. So this is in gradient intercept form, and xy will be equal to the inverse matrix, this is it, times the constant matrix. We open out and multiply, and we will have x equals 5 and y, sorry, here is y equals minus 1. X equals 5 and y equals minus 1. This is another beautiful one. A man bought a bottle of champagne, C, and 2 bottles of wine at 8,000 francs, while another man bought 2 bottles of champagne and 3 bottles of wine for 14,000 from the same shop. Write equations for champagne and wine. So the first man bought a bottle of champagne, so 1C plus 2 bottles of wine plus 2W is equal to 8,000. The other man bought 2 bottles of champagne, so 2C plus 3 bottles of wine equals 14,000, and we can, these are the equations. Now calculate the cost of each, a bottle of champagne and a bottle of wine. They just want you to solve for champagne and wine, okay? So we can solve by substitution or by elimination. So from here, if I subtract directly by elimination, I'll have equation 2 minus equation 1. Wine will be 2,000. I substitute in the other equation. Substitute this value in one of the equations. And what are we going to have? We have C to be equal to 4,000. Okay. So we have C to be equal to 4,000. My 4 was not written. Okay, so that is it. So I've balanced, you can start this equation, say I had to do some balancing. That's why you have it in this form. And this last but not the least, you have this, find the points where they intersect. They just want you to solve this equation, okay? So we do substitution. You can solve by substitution directly. Why is it good to use substitution here? Because they've already made y the subject of the formula. So it's best to use substitution here. So I'll just take this my equation 1 and substitute equation 2. So I'll have 3x plus 5 into, instead of writing y, I'll write 2x minus 12. Then we expand. We expand this. We'll have 3x plus 10 minus 60 equals 5. Bring like terms together, we have 13x equals 65. 13x equals 65, and x will be equal to 5. So if x is equal to 5, we substitute one of the equations, we'll have a y to be equal to minus 2. So this is the solution set. And the solution set is an ordered pair, x before y, okay? X before y. So this is what we have. So the answer here is C, or the key here is C. Thank you. Don't forget to subscribe. And the next part is on quadratic equations. Join us on Facebook, GCE Math Panel Online, and other platforms. Bye-bye.